So this session is going to deal with where there are non-standard situations that occur often enough out in the field, excuse me, that they've gone and tried to do some testing for designs that will fit those general situations that are non-standard. However, just identifying how we don't have all the answers, we had some discussion yesterday, instigated by Mr. Ali, about the alignment of our type 38s and the type 21s. And I said, as he was strongly emphasizing, it must be on a straight line. And this slide, people in coming to this afternoon session will see again, but designers will not be hearing it again. So we must emphasize you have to address this in the plans so that we don't have to have a change order or something to extend the rail through a radius. Now, Ali is working on coming up with what type of radius can we get away with and put a straight line on. I used to say this was only applicable to the compression base, the MSKT and the SGET, but as I said yesterday, the manufacturer of the tension-based one, the soft stop, because it was tested in a straight line, they are gun shy to do anything applying engineering judgment, and so they make the same statement throughout their manual that it must be installed on a straight line. Now, if you look at this photo on the right here, if I put a string line at the end of this 50-foot section and pulled it back to the last post, I could put a straight line in there with perfect grading behind. So in this case, if this was all I needed, it looks a little short, but if this were all I needed to shield whatever hazards we're attempting to shield, I could just pull that line back, lay the terminal out on that straight line, and I would satisfy, even though it is on the curve. The terminal itself is what needs to be on the straight line, okay? Otherwise, with this, when you hit on the end here at a shallow angle, you're trying to shove this head down the rail has been bent. We've broken the axial strength by putting a bend in there, and we'll probably get a kink right about there, which could be disastrous. It could work okay, who knows? We don't want a who knows. We want to, you know, the advertisement about probably good enough. Well, we want to know it's good enough unless we can't do anything else but, okay? So the instruction, we talked about this after the presentation yesterday, and Ollie's preference is that the rail, the barrier, be extended around the radius, add the extra length in there to get to where you can install it on a straight line. It doesn't need to be completely out of the curve, the horizontal curve, but to where you can put it on a straight line, as each of the manufacturers insist. And again, Ali is looking into this. There may be some future modification to that, but as of today, the instruction is for TDOT, okay, it needs to be on a straight line. The second item that we had some discussion about was length of need. Now, both sessions today are going to talk about length of need for designers ad nauseum. Now, hopefully it's not ad nauseum, but so that you have a full grasp of it, because remember, it's the third and probably the most important of the deficiencies, the three deficiencies we see in barrier. And remember, identified length of need is how much you need effective barrier in advance of the hazard you're trying to shield. And for a type 12, the bib, the point where I have effective barrier, where it ends, is where the face of the rail crosses the toe of the slope, okay? And I just want to go over this. I know it's a repeat, but Some people indicated afterwards in the chat about they were aware of the Memphis situation I mentioned where the kids were killed. If we have NTSB, the foremost American institution on traffic safety, saying that this is the worst thing going, okay, we don't want to give them ammunition to counteract what TDOT says in the design guide, that it's the first choice. So as I said yesterday, it is the best thing going when it is designed and installed properly. There's two parts to that primarily. One is the slope in front. If it's 10-to-1 slope, it can be a single rail, height measured from the ground. If it's steeper than 10-to-1 to as steep as 4-to-1, then you hold that top rail, as it says in the standard, as if it were at the grade on the profile grade line until you meet that 45-inch maximum or until you cross the ditch bottom, and then you bury it. If you have to hold it up, as soon as you exceed 18 inches or 19 inches under the rail, you add the rub rail, okay? And the second aspect of that was having enough. What happened in Memphis was the back slope they tied into was a 3.4-to-1. That is a lot flatter than our typical 2-to-1 and can easily be driven on. And rather than doing the length of need analysis for it, they used a minimum, 60 feet, something like that, 50 feet. And it was, the vehicle went right over the end, as anyone would expect, and had very little run out distance before they got to the concrete wall. And that's what happened. What we don't want to do is violate those two principles, having adequate length of need and having the slope in front properly addressed. So we talked about if you had a rock cut, all you have to do is establish the tension. You're not going to climb a rock cut. But if we have the typical 2-to-1, you can't get up behind it. And that's where we want to have that minimum 75 feet from the beginning of the hazard to the point where the face of the rail crosses the toe of the back slope, okay? And that was the high speed, okay? If it were flatter than the 2-to-1, such as in Memphis, the 3.4-to-1, you're going to go through the calculation that I'm going to show you for the design as if it were any other terminal where you know that the point where the BLON is, where it crosses the ditch bottom, okay? And if anybody has a question on how to do that, we'll discuss it at the time. But I did want to address those two issues from yesterday. Hopefully it's fairly clear and we can move on. So getting into session 5 is for the places where we need a design to fit an unusual situation. It doesn't fit the standard like at the airport, and we've spent the money to come up with a design, or we've made an administrative determination, okay, that this is what we can do. These are several situations that occur. The first one, you have a place where you're driving your post every 6'3", and you come to a place where, oh my gosh, there's a culvert. It's only 18 inches under the ground. If I drive the post, I'm going right through the culvert. Or there's a utility marking. If I drive a post, I want to disrupt the national, FiOS or something. So we'll talk about what we can do there and some things that we're progressing forward on that aren't there yet in the standards. I talked yesterday about if we want for the guardrail to perform, ideally to have the post push back in the soil a little bit before it fails, plastically deforming the soil, absorbing some energy, making it less stressful on the rail. We'll talk about how to do that. One of the biggest problems is guardrail at, I have intersection here because that's what I have the slide for, but anytime I need to leave a break in a guardrail run, probably more often at driveway access. We'll talk about that. One of our biggest problems nationally, what to do about it. We'll talk about extra blockouts, what Federal Highway has been preaching, and what TDOT has, okay? There is a difference. And then guardrail and rock, how TDOT addresses, since you do have rock that is not deep enough below the surface to get a full depth embedment by driving. We'll talk about what TDOT's guidance is on that. Okay, leaving out a post. Many years ago, back in the 80s, okay, we finally did some research to say, can I leave a post out? This is the old G4 27-inch system, okay? And they went and they said, yeah, you know, I can leave it out, one post, if I nest the W-beam over the span and at least 6 feet on either side, depending where the splice was, okay? And this was issued for everybody to be able to use, and they liked it. In fact, they liked it so much, they said, well, can I leave 2 posts out? And they went and they tested that. Now, this is testing with the big sedan, okay? And that worked too. So same thing, nest over the span, which is now 18 foot, okay? And extended at least 6 foot on either side, okay? Well, they said, you know, well, what about 3? And they actually went and they did a test, and this was to 350 with a pickup. And the result was they needed to have 100 foot of nested rail centered on the middle of the span, and the 3 posts on either side of the span, because there's going to be a lot more deflection. They didn't want a pocket on a more rigid post. They put in what I'll call a soft post, a breakaway post, okay? And that was acceptable on the 350. Well, now we're in match. What do we have, okay? Again, and that was the old system. Now we have a better system, okay? So actually, I saw this last night. This is going to be a repeat, but I'm going to show you, okay? So here I have the MGS system. I took out 3 posts. I put it not over ground, but I put it over a culvert head wall that was no higher than 4 inches, okay? Took out 3 posts, did the same thing, put in 3 weakened posts here, and then I hit it with the mesh vehicle at 62 miles an hour, 25 degrees. Let's see it. Okay, pretty good performance, smooth redirection. It goes out over the void, but because it's engaged the rail and it's up against the rail, it just keeps on going down and we get a safe traverse, okay? Now, notice though down here on the left, working with, which is related to deflection, is significantly more. Remember we had 54 inches, I think, for the 8-foot post on the 2-to-1. So we got 40 more inches of deflection, which is fine as long as you've designed for that, okay? So this was testing done with the great MGS system. Based on that, there's been some further development done. But for TDOT, right now, what's in the design guide says, if you have a place where you have to leave out a post, okay, you go to the standard, and we'll see that in a second. If you have to leave out more than 1 post, you go to the standard GRS 3, and that's building a pad, a concrete pad, to mount the post to, if you can't drive it. We'll see that. So as of today, TDOT does not have something representing the video you just saw. And even as we're going to see on the -1, okay, here we have the -1. Well, we have a missing post in here, okay? That's fine. It's a 25-foot panel shown, except it says that over this panel, it will be right here. You probably can't read it, but if you have your standards available, you would see that says nested rail for 1 post out. Well, we took 3 posts out and we didn't nest the rail, but we changed the post, okay? Well, if it's good for 3 posts out, it's good for 2 posts out. Good for 2 posts out is probably good for 1 post out. But then we have to go to the yard and bring out 6 of these special wood posts. Here with your system, your standard, you're just using standard post, but you are nesting the rail for 37 feet, okay? Well, some people said, you know, this system is so good. Yeah, you took 3 posts out and you had to come out with those wood posts. I'll bet you if you just take 1 post out, do nothing else, standard steel post, but no nesting, okay, it would work. Now you can see I put up here developing, okay? So always aware of this, and if you ever put in guardrail, you know that nesting rail is not a nice thing. So this is much simpler. And as you're going to see in the next video, it works very well. And actually the deflection is not that much more. Look down the lower left, okay, 50 inches with the steel post. I believe it was 48 inches with the steel post, having all posts in there. Well, we're not going to say, well, let's take out every other post. Okay, we're not going to even say take out, well, we are going to say limit 1 post out every 50 feet, but we're not going to say, okay, every 50 feet, take out a post. This is just a tool that's simpler than the current standard requiring the nesting, but only to be used when absolutely necessary, okay? Now, I was just told I have a question about nesting, okay, and Devin, I'm not sure, okay? To me, stacking is the type 12 where 1 rail is vertically on top of the other. Nesting, I actually asked my boss's daughters if they knew what spooning was, and they knew. So I don't know whether to ask you all, well, and they're only 13 years old, okay? If you know what spooning is, it's 2 rail elements spooning. If you don't know what spooning is, I'm going to be showing a standard that shows. Actually, I just need to go back to your standard. Right over here on the left, okay? Nested rail, 1 element inside the other, okay? But it's hard to construct, especially when you come to the splice where you have 4 rail elements there. Just ask the contractor, okay? So getting rid of the requirement for nesting is a ease of fabrication, and we're not losing probably anything in performance, okay? So you saw how well it performed there. So here's the -3 that if you have more than 1 post, your standard only allows 1 post to come out in nesting, but no changing to the post. So look for possibly in the future, 1 post can come out, no changing of the post, and no nesting. But if you have more than 1, what the current standard is in TDOT is you go to this 5x5 concrete footer reinforced, okay? And it shows you can go up to 3 of these. Actually, Pennsylvania uses this when they have more than 3. They use the 3 post out with just the weakened post on either side, but they are concerned there's going to be places where they have 4 or 5 or 6 posts they need to leave out. They went and tested this, essentially the same thing to MASH, having 6 posts out, excuse me, not out, 6 posts mounted to the concrete slab, okay? So this is fine. It's just, it's a lot of work, a lot more work than taking the 3 posts out and putting 6 wood posts in, weakened wood posts on either 3 on either side. So it's just another tool that Ollie's considering to whether or not to include. Like I said, I only played once yesterday. I'm not going to show it to you again. You've already seen it. Oh, the anticipation. I'll go ahead and play it out. Okay, so pretty good performance. Okay, now we may have a longer situation like a double, triple box where it's actually at grade. Okay, the deck is the riding surface, and you have a standard to address that, where you just mount the post, pretty much the same as what we saw in the previous standard of mounting the post on slabs. Okay, so that's things that happen in the field. I'm not aware where this has been tested to MASH, but again, until it is, this has been the standard. There's no problem with it. So we'll continue to use it until somebody comes up with something different. Well, guess what? People did come up with something different, not for this, but what about this situation? Okay, it's not the riding surface. The top of the slab is down here, maybe 12 inches or so, but that's not going to let us drive a post. Well, we'll just put it in the air, put a couple bolts into the concrete head wall, and we're good to go, right? Well, probably not so good, okay? So what we have in the standards, the -5, is what we call the weakened post, weak post attachment to the culvert. This has been tested to MASH, okay? And it works somewhat the same as taking the post out. These are weakened posts, okay? But now this can extend 50 feet, 100 feet, okay? But every 3 foot, 1.5 is the post spacing now, and special mounting and special wood weakened posts. But now we have something to address the situation from the last photo, okay? So this is to the latest and greatest. So these are all different situations on being able to take care of when I can't drive a post, okay? The left out post alternatives. Second thing we want to talk about is leave outs, not leaving out, but leave outs. In order to allow that post to move backwards some before it fails, I need to have normal strength material. If I'm putting a post into shoulder pavement, or in the case you see in the photo on the right, this is a mow strip. This is concrete, 4-inch thick concrete, okay? To prevent growth and not have, it's a maintenance favor, okay? If you put a post right in the middle of that, okay, it would not be able to push back, deform the material because that concrete is too stiff. Well, you say, well, there is concrete there. No, it's not concrete. It's a grout, a weak grout, 120 PSI, okay? Less than 6 inches thick. It still will stop the weeds, hopefully, but it will still allow the post to move back. So this is the intent of the leave out. Whenever you have structural pavement for whatever reason, and structural pavement thickness has not been defined, is that 2 inches? If you're just putting out erosion control paving like, doesn't define it, okay? But you don't have to worry about it because right now, there's nothing in the standard to address what to do about it. And just to put this in perspective, when this was presented, there was a gentleman from Minnesota got up and said, now you're telling me that for 6 months out of the year, because of our permafrost, or not permafrost, but frost penetration, my system's not going to work. And the presenter really couldn't say much. So it's not that it's not going to work. It's not going to work ideally like what we would want it to do. So when we can do it, this is the national guidance. Again, it's not a requirement in TDOT. Just be aware of it, okay? Now, we want to have, in order to allow that movement, a minimum of 7 inches. Let's look over here at the photo. We drilled a hole that was maybe about, not drilled a hole, they constructed a leave out that was maybe 18 inches. And what did they do wrong over here? Unbelievable. There was supposed to be a flying X. Well, they made it look nice. They put it right in the center of that 18-inch hole leave out, which did not leave me the 7 inches behind. when the leave out was made, the post, it should have been offset so the post was towards the front, as we see over here in this section. Okay, so that we have the minimum of 7 inches for movement through the weak grout or, you know, just regular milling material or whatever. Okay, so that is something in the national guidance about how to do leave outs. Here's our biggie. Okay, we have, looks like a public road coming in here, and we have a real bad hazard here. And we could, in some states, do this, just terminate the parallel runner rail with a type 38 or type 21 if it's a medium speed, okay? Because, they say, this is untested. Remember I said that for the barrier to work, it needs tension. Well, if I left the road and came at this post, how much tension do I have at this post? Not very much. You don't see any cable anchor down here. You see that I would have 4 bolts holding the rail to these posts. So I have some, but many times it ends right here or it ends right here, okay? Generally, I don't have much tension for a hit on the radius or beyond. So what do? Well, if this is a public road, I could extend this farther down. Well, maybe that's good, maybe not. And how do I know this will work if I hit here, if I just put a steel post in and put a block on it, just standard 31-inch rail coming around there? Well, I don't. We've never tested it. In fact, we never probably will because nobody thinks it will work. Okay. So what do? Well, in TDOT, you as a designer have guidance that says when you have this, you will go to the SPL2 and you will use an inline anchor along the main road as called for in SPL2 to develop tension along the main road, okay? But we'll look at SPL2 coming up. It has several alternatives. It says when you can't do this, because to use any of the alternatives in SPL2, you need about 25 feet going down the side road. Well, if it's a public road, you can generally do this. But if it's a driveway, I don't think you got many people in Tennessee who want the last post driven in the middle of the living room. So we have the special -4, we'll look at it. Okay. So here's just one of the alternatives in the SPL2. This is for when you have a side road. There's another alternative that shows if you have a driveway. Okay. But again, it goes around the radius and extends down. Now, the radius can be as tight as 15-foot radius, but it still takes distance down perpendicular in order to develop the tension, because now this is not going to spread the tension as we've seen in the redirection test on hitting on the side up here. We have tension. Here's that inline anchor, okay? We have tension if we hit along here. It goes back and goes down through the cable. But the tension that's developed in a hit on the nose here of the radius someplace is like a spider web. Okay, and it's going to need to be pulled from this side and pulled from this side. And it's going to have a big deflection in here. And that's why we have this area here, the table 1, that says you need to have an area that's clear to allow for this large deflection here. It can be a 2-to-1 slope, but it can't have any vertical rigid object that's going to stop it from continuing to move out here. And so you have the dimensions of what this area clear behind here needs to be. Same for on the driveway. Again, it's just tough. This has been, the one that's for the driveway was tested back in the 80s, okay, at 50 miles an hour, and it worked, okay? And so this is just an extrapolation. You can see there are no blockouts on this radius, okay? And it's wood post. It is not the steel post, which we would be afraid would bend over and the vehicle would go right over. These would be the weakened wood posts that hopefully would just shear away, allowing this rail to wrap around the front grille of the vehicle and bring it to a nice controlled stop right back in here someplace. Okay? Well, if we're trying to meet MASH on all our new installations, we would like to have something that meets MASH. Well, here's something that meets MASH. This was tested in a pooled fund study by submitted by TxDOT. Okay, it uses Thri-Beam. It puts safe barrels behind. It's got cables in here. But guess what? It works. Do you think you're going to build it? Texas didn't even put it in their standards yet, okay? Well, there was a study done that Ali's been waiting anxiously for. He keeps telling us because Karen's company has the contract to do it. So you're going to get to see a video that's not been released. This is what you get for coming to visit with us. So here we have a radius, okay? In this case, we're saying it's because we have a bridge right here, but this could just be rail running on like in the previous photo. And we're going to run this 5,000-pound truck at 62 miles an hour right into the center of the radius, okay, at 25 degrees to the main line. You think it's going to work? Let's see. Oh, guess it didn't. Nope, it does. Well, now I took the... This is 62 miles an hour. The rail wraps around. Whoops, the rail's not wrapped around anymore. How's that stopping? That stopped that truck just like a crash cushion without the rail there. It's invisible force. No, there are two cables in this. This is 10-gauge rail wrapping around, and it has two cables associated with it that will, if the rail doesn't engage, the cables will engage and be able to stop this vehicle, 62 miles an hour, okay, right into the center. So this is still in the research phase. It has not been submitted for publication yet, but it's on its way. Okay, it's out for review. Okay, what does the -4 tell us? Well, it tells us we can't go into somebody's living room, okay? So here, if we have a driveway and we have to leave an opening in the access of a standard run of rail that normally would extend right across the driveway, the last alternative, if you can't put in the ones that were tested, even the old testing, which run down here to develop the tension, you come along, you put an inline anchor in for the main line roadway, and you put a radius around, standard steel post, it doesn't matter, it's just going to push over, okay? But it's not going to spear you, hopefully, okay? So this is what we have in the standard to address at a driveway. As I said, some states will go, and this is not cheap, but it's not that expensive. Some states will put a type 38 on the end here, and for two-way traffic on the end here, okay? That starts running up in money. This is what TDOT has given you to use, okay? Not crash tested. Actually, we do have, that being said, we have an 8-foot radius that has been crash tested at 60 miles an hour, okay? But not to MASH. And so it's not in published literature anymore. It was approved by Federal Highway, okay? But it's not in the published literature anymore, but it may be something that we should try to replicate exactly to have something that we can say, well, we tested it at one time and it worked, okay? But you have it anyway at the radius that needs to be used here. Okay, so that's it for the most difficult problem we have along all our roads. What do we do at access points? And again, even that video I showed you from the study still requires development attention along the side road. And so it's not going to be good at driveways, maybe at field entrances. If you can put it out if you get the farmer's approval, but it's not going to be good at somebody's driveway where they're right along the roadway. What do we do about if we do have the rock? Well, we have two different situations in the national guidance, okay? We say if there's less than 18 inch of overburden of soil to the top of the rock, I treat it by drilling, coring into the rock, 24 inches minimum, or to the depth to get the full embedment, okay? I will drill that not with an 8-inch core, but with for your steel post, a 21-inch or a 23-inch for wood post. That again is to put back material that will be able to crush, deform, allow the post to move. This is essentially into structural pavement. It's the same concept. If you got more than or equal to 18 inches of dirt on top, we're saying we got a lot of movement allowed up here in that 18 inches. Now you only have to drill 12 inches into the rock, and it can fit the hole, 8-inch for steel, 12-inch for the wood, okay? Well, you know what? I couldn't find a standard for this. So I guess TDOT, you don't have any rock, Tennessee, right? No, you do. You go to your spec, and it says exactly the same thing, okay? If you have less than 18 inches, you will drill the 24-inch elongated hole and backfill. It doesn't go into the, and then it has the second thing that says, if it's more than the 18 inches, exactly what I showed you in the picture, and this is perfect, okay? Now, when it gets to the terminals, this is for standard runs of rail. When it gets to the terminals, remember we talked about developing anchorage for a cable or something at the very last post. We have an anchor. That post must be totally in a minimum by the spec, 36 inches into the rock, okay? Or to the depth as shown by the piece of hardware that we're putting in for the two anchorage posts. Beyond that, you can follow this, okay? This is to make sure we don't get what happened back here in the early 2000s with the cutoff post, cutoff steel tubes. And if we didn't know we had the rock underneath there, there's a very nice item here from the, okay, that addresses how to pay for it. You're just going to pay 2 times the contract unit price for lineal foot of standard regular guardrail, okay? So very nice. Not the right way to do it. We don't know whether 2 times is right or not. We should have a bid item for it, but this at least takes guesswork out if we missed something. Okay, what about extra blockouts? If I drive the post, I'm going to hit something, but if I move that post back just 8 inches, I'll miss it. Well, 8 inches, that sounds like a blockout, okay? So can I do that? Well, we have not tested it that I'm aware of. I'm still waiting for Ali to send me the study, okay? But nationally, it's always been accepted. Say what? He did, okay. Thank you, Ali. Karen just told me he sent it, okay? It's nice to have support to back up. But this was always accepted even before the study was done, that you can put in 2 blocks, okay? Remember the purpose of the offset block. It's to minimize the snagging on the bottom of the post as it goes into the ground. Well, what if 16 inches doesn't do it, but 20 inches would? Can I put in more than 2, but no more than 3? I can't even count as high as we have here. But this is a different situation. This is where I've already stiffened up. Look at the spacing. I'm probably okay here. But for the standard runner rail, remember what I said happened? When the bumper hits the rail, it starts to push the whole thing backwards. The rail is supposed to come off the bolt. But as it starts to push back, if I had more, or if I had 4 blockouts back here, the first thing that's going to start to do is lift up as the post rotates back. And as it lifts up, before it releases, I may get the smaller car going underneath. We're concerned about that. So what we said nationally, okay, Federal Highway said, is you can put 3 blocks, but generally only 1 within 50 feet so that it will rip off that bolt head before it starts lifting the post. Now, the roadside design guide said something else, and what Ollie sent me is, in your circular letter 70505 that you should all have, it says allow a maximum of 2 additional blockouts on 3 consecutive posts, okay? So even though this says generally only 1, you are allowed to have 3 blockouts for 3 consecutive posts, okay? And that comes in handy a lot of times. Okay, next issue that we have in the field a lot, maybe we had this barrier here shielding this sign support, and this meets all the criteria, and then something happened back here that we needed to put rail in. I think it's actually the other way around, because this is older rail, because it doesn't even have a cable to develop anchorage, okay? But anyway, we had a gap between the end of one and the beginning of another. Okay. Should we leave it open? Well, come back here in 10 years, and this tree, if it's open, you go through here, you're going to have a very abrupt stop. Actually, getting across this ditch is probably not an acceptable ditch. So regardless of the cost, because we have to pay for type 38 here, this is freeway, okay, and pay for type 13 here, if I just filled it in with standard guardrail, it's probably going to be cheaper. But as you saw in the videos, hitting this at a shallow angle is bringing you Usain Bolt running into the wall, okay? Not nice. So as long as you don't need access in here, fill it in. And if they don't match exactly the splices, you can make it match in the field, okay? Before you fill it in, whether you're in design or whether you're out in the field, if design missed it, make sure you check with everybody. If you're in the field, they're calling you in design to see that you've gone through and coordinated and found that there was a reason you had to leave it open. Okay, they don't do the coordination. Okay, well, what I don't have on here, and I don't know why, is how big a gap between filling it in versus not filling it in. And so you can write in your notebook, 200 feet is the typical. I don't see where TDOT has addressed this. So, okay, I do have a note here from Emma again. Thank you. On design plans, what would be the proper way to call that out other than work it out in the field? Is there a standard for connecting new guardrail to old guardrail? No, there's no standard, and yes, I would just be silent on it. It's very simple. Since this is design, I'm not addressing it. I will address it in the construction. How's that to entice you to come back this afternoon? No, you can drill 8 holes any place you want in a piece of rail to make it match. You have the template of the existing splice end, the end of the rail, and wherever that falls on the other rail that you're lapping over, you just drill a 7/8 inch hole, round hole for the 8 bolts that you need in the splice, wherever that occurs. So it is just to work it out. Good question. Okay, but one thing we do not leave just to work out, the new rail is 31 inch high and the old rail is 27, maybe 28, okay? And we don't say just work it out in the field, because that was a great segue, Emma. Thank you. Okay. Because we have two things. We have to adjust the height, and we also have to get the splice off the post. So TDOT has a standard, SGRS 4, where they go over 25 feet from the 27-inch up to the 31-inch. And then they put the extra post, and we have all kinds of variation where this extra post is to get it off the splice, okay? But they put it in on the high side. Some people put it in down here on the low side. You have a standard, follow it, okay? So we just take this post here, okay, and move it over to here. Very simple, but there is a standard to follow. And that brings us to the end of those special situations, okay? Any other questions, great questions like Emma's? We are going to, okay, Jessica, I don't know whether it didn't come through, because I see it. Why would there be a gap there, and is that a common issue? So we're talking back up here where we have a gap. As I say, it's typically where something comes along at a later time. Or it's somebody who's so focused, okay, I did my length of need analysis and shielding analysis for something back here, and then I didn't even look at that again. I went up here on the same project and the same set of plans and started another one, okay? It happens, believe me, okay? But more often than not, it's where something comes along subsequently. And so when they're looking at that, they shouldn't just blindly go out and say, okay, I'm going to put this in. They should see what's out there and evaluate the whole system. So sorry, I didn't mean to miss your question here. Great question. Thank you. Okay. You're so nice. Okay. So it is 9:22. We've been at it almost an hour. Guess what? In the next one, you're going to work. I'm going to blab at you, as Matt said, for a bit, telling you all about length of need, and then you're going to work. And we're going to go until you're done working. I'm going to be done blabbing about half an hour. You're going to work for a while until I say that's it, and then we'll go over what would be the one solution, one that I have. You may have something better, okay? There's many times different ways to skin the cat. Some are better than others. I'm going to give you one alternative. But go get fortified with whatever you need. Please bring back your calculators. And we will take a 15-minute break, which now it's 9:23, we'll call it. We'll see you with my math at 9:38. Okay. Hopefully everybody's back, ready to go, have their sleeves rolled up. And first, I got to yap at you, as Matt said. I'm not going to let you forget that, Matt. Okay. So we kept hearing length of need. Okay. So now we're going to absolutely have it clear what is length of need. Now, that being said, how it's one of the three biggest deficiencies and how it's so important, I'm going to tell you that probably, I'm going to just go out on a limb here and say 75% of all barrier installations throughout the country cannot get length of need. But many of them can get more than what they do get. So understanding the principle and getting as close as you can, but when you can get it, you should be getting it. Okay, so let's get into length of need. End of the session, hopefully you'll be able to teach a class to some college on what the length of need is. Then we're going to just look at some examples out in the field that make me cringe, okay? And then you're going to work doing a simple, notice the word simple problem, okay? A very common problem. So the definition, now I say the definition. This is the definition of this class. You go to the roadside design guide, that basic document I told that this was based on, you get two different definitions. They can't even get it straight just in one book, let alone different states have different definitions. So for the purposes of this, this is the first definition in the roadside design guide, and it is the amount of effective barrier. It means it's fully effective. You hit it, you're expecting to be redirected. And that is in advance of the beginning of the hazard. Okay? From the beginning of the hazard to the end of the hazard, that's just the barrier needed. Okay? But the length in advance, that's part of the total barrier needed. The length in advance is part of the total barrier needed, but it is before you even get to the hazard, because vehicles leave the road in advance typically, okay, or they can leave in advance of the hazard. And almost always, if it's a point hazard, like a sign support or a column or something, if it's a fill that's 2,000 foot long, length of knee is going to be a very small part of that. And most hits, most interceptions of somebody getting into the hazard are in the normal run of the barrier, not in the length of knee portion. Okay, bunch of words, you don't understand what you're saying. Here we have a hazard. That says that everything upstream, remember upstream is as you're coming, you get to upstream, and then you go down, you get to downstream, okay? Everything upstream of the hazard is runout area. It's clear zone that you can drive in, that you've accepted, or it may be like a 2-to-1 cut slope that you've just accepted people can drive on, okay? But there is no hazard that I'm trying to shield in advance of this point right here. That's physically defined, going out there and looking at it, okay? And what the theory of length of need, how to determine length of need, there is some distance, we call it L sub R, a runout length, a defined distance in advance of the hazard, that if you leave the roadway at any angle at a distance greater than that specified distance, you can come to a stop before you get to the beginning of the hazard. Okay? Very simple, not defining any angle, any path, okay? But it's long enough distance that we're going to define that if you leave in advance of that, you will not get to the hazard. So what's the problem here? How do I define L sub R? Well, for about a decade or maybe even more, we had a tremendous battle between what values should be used, the values that were in the original roadside design guide and the values that we use today from the roadside design guide or from SPL1, okay? But we have values set for a given speed, it's going to be higher, and for a given volume, the higher the volume, we're going to provide a longer distance. Volume has no effect on how far you're going to travel, but it has an effect on economics. And we're going to spend more money, put in more barrier when we have more exposure. Okay? So it's really easy for us practitioners. L sub R is just a lookup value off of a chart. Okay? But it's based what L sub R is, and that's very important on the effect it has on how much barrier we need in advance of the hazard. Okay? Well, there it is, right on SPL1, based upon speed and based upon what the volumes are, we have distances. These are pretty, excuse me, I thought I was going to sneeze. Pretty long, look, there's a football field, okay? And this is going to give you long runs of barrier in advance of the hazard. And that's why we don't get it sometimes. But remember I said, this is the latest values. Previous values, this was 480. They got reduced 25%. And it's almost an exact ratio of how much we lessened it to how much less barrier we're putting out there nowadays than what we would have put out there 15 years ago or so when they changed. Okay. So what else we have in SPL1 is we have a nice little sketch, figure 8, B, whatever it is, okay? To figure out, we identify the hazard. It may be 2 feet, it may be 200 feet, it may be 2,000 feet. It has a length, and we're going to be putting barrier in front of that. But we're also going to be putting barrier in advance of it. If it is a one-way roadway, we will only have it on the upstream side. If it's a 2-lane roadway, then we're going to have the LON far side, okay, for people coming the opposing direction, crossing the center line, and heading towards our hazard coming this way, okay? So it's very easily laid out to you. We're going to go through what all these L1s, LA, all that, so that you have a good understanding. But I'm going to tell you there's 3 things you want to keep in mind. L sub R, which is a lookup value, okay? L sub A, the distance from the edge line to the back of the hazard. It's a physical measurement, okay? If that hazard, let's say, is a river and goes on forever and empties into the Mississippi or something, okay, the Gulf of Mexico, we are going to limit LA to no more than LC, the clear zone for our project, okay? And the other major value is going to be L2. What is L2? It's the offset of the face of the barrier from the edge of the traveled line, okay? Those are the 3 values that are going to be most important. L3, the offset from the travel line to the face of the barrier, of the hazard. Well, L2 we want to maximize. L2 will never be more than L3. And if the hazard is a vertical rigid object, we're going to have a deflection distance behind the barrier to provide one of those principles. If I don't have a flat surface all the way out here, okay, I am going to be limited to where I place my barrier by the principle of slope in front, okay? So L3, again, is just a physical measurement to the front of the hazard, which is going to control the principles. We have an L1. What is L1? It is actually the distance from the beginning of the hazard that runs parallel, the barrier runs parallel to the roadway. We talked about the benefits of flare. If I can start to flare, I pick up the benefits we went through yesterday, and I can lessen the amount of barrier I'm going to put out there, as well as move the barrier farther away, the advantages we talked about yesterday. But L1 is only if you are flaring a barrier. If you're running it parallel, which is most of our installations, I'm not talking about the terminal, we'll talk about that, okay? If you're running it parallel, then L1 never enters into consideration, okay? So L sub A, the back of hazard, the offset to the face of the barrier, L2, the L sub R lookup value for the speed and the volume we have, and we're ready to go, okay? Sometimes defining the hazard is a little more difficult, and the majority of sometimes is if it's a fill slope. If it's a fill slope that we're saying we are going to shield it, we have to define where it starts. And there's good examples in the roadside design guide, but I'll give you, remember we had a critical slope chart based upon how steep the fill was and how high it was. And we said, if at the bottom of the slope, there was nothing of harm, the beginning of the hazard would be where it gets steeper than 3:1, okay? Anything in advance of that where it's not steeper than 3:1 and I can go to the bottom, That's not a problem. But remember now, that's not where I end my barrier. That's where I start to calculate my length of need. Many, many times we see the application of barrier installation where the beginning of the barrier is at the point of the hazard. Okay, this you need to be careful of. Okay, so we have the parameters identified. Here's the equation. We have that LA I said we have to be able to define, limited to the clear zone. Excuse me. We have the offset. Down here we have same LA in our lookup value of LR. We got an extra term in here, 0.75. And you go to note A. Remember, we are supposed to have a 1 foot offset for our type 38s, our type 31. Okay? That moves the beginning of length of need point, which is 3/4 of a foot, okay, farther away. So I've increased my offset. This really could be put in parentheses as L2 plus 3/4 of a foot. Now this is going to be, again, with the new terminals we're using, it's not exactly, but it's good enough for government work. But if you cannot flare it, if you're on a lower type road and you cannot, I don't mean flare, but offset that terminal, that 1 foot, you drop this term out. It's in there only because I have flared the terminal. Okay? And that can be account for at least another stick of rail. It's very good to have it in there, but make sure you understand why it's in there. And if it's not appropriate to be in there, get it out of there. Okay? So the legend here, exactly what we went through, and hopefully I don't need to go over it again. Now, TDOT has something that's beyond my simple mind. Actually, I probably could follow it, but what do I do on a curve? What we just went through here, this formula is fine on a parallel, a tangent installation. Okay, if it is a flare where I'm using L1, you're going to have to go to the roadside design guide and get the extra term you're going to put into this formula, which is the flare rate that we talked about yesterday. It gets inserted into the formula. This is for a parallel installation. Okay? But it is not appropriate for a curve. All this is determined by is just plain geometry, similar triangles, okay? That's all we need. But if I have a curve, I don't have that application. Well, we're still going to use the tangential application, the simple formula, as long as that curve has no more than a 2,000 foot radius, unless Ollie puts out something else, okay? That's a soft enough curve that we're not going to have to go through the complication here. And this is not an exact science, okay? Remember, we had this argument about L sub R for a decade or two, okay? So if it's the curve on a high type road is more than the 2,000 foot radius, then just use the formula. But you're going to have a whole bunch on your local roads where you got 700 foot radiuses, 500 foot radiuses, 300 foot radius. You're going to have very smaller radius, okay? So what TDOT has given you is a way to calculate out with the arc signs, okay? I thought there was archangels. I don't know what an arc sign is. But anyway, it's a very strict application of the math to determine where this length of need point would be in advance of the hazard. Okay? And I'm not going to go through it. The example problem doesn't use it. You should be able to follow it. It's very well spelled out down here. okay? How you go through and you calculate A, then B, and C, and this tells you all of it. It's very straightforward. You better have your computer with you or your calculator because you do have these arc signs to figure out, and you'll come up with a number. Again, the distance from the beginning of the hazard to the point on the terminal where you have the beginning of length of need. Okay? But I'm not going to go through it. That class starts at 7 o'clock tonight. Anybody who wants to be here. That's it. Okay? I see a question here from Steve. Under the legend LA equals. Note that LH should never exceed the clear zone. Shouldn't this say LA? No. Okay? Why I say no so vehemently. Don't go tunnel vision. And this photo I have up here is a good example. Okay? There may be something you say never exceed the clear zone. What if I have a drop off into a quarry? My clear zone is 32 feet and the drop off into the quarry is at 33 feet. Do I say, I don't worry about that quarry and people dropping into it because it's outside my clear zone? No, this is not a class on roadside design. This is a class on barrier, but please do not get into the fact that clear zone is an absolute. Remember the table that's in the clear zone standard. It has a range. It is not an exact calculation. Vehicles don't know where the clear zone ends. So never say never, okay? And here's a good example right here. Well, let me get to it after I go through the first part, okay? I have barrier here. Always the first question when I'm putting in barrier is, what is my hazard? So here, I have a definite hazard here, the end of that parapet wall. I better shield that, not with a delineator object marker, okay? This is a freeway, okay? So obviously a high type road, just a delineator is not acceptable. So they come in and they put a transition, guardrail to bridge rail transition in there. Maybe they have 25 foot of rail, and then they have the old type 38, okay? Does a great job of shielding the one hazard. But the point I want to make to you all is you must evaluate the location, the site for all warranting hazard. What is a warranting hazard? It is a hazard that in and by itself would be shielded. Take that parapet wall off of there. Extend out the shoulder for 20 feet. You still have a drainage channel coming in there. You probably have at least a 30-foot clear zone on this. You would want to shield that drainage channel. So in this case, I have a hazard of the parapet, but whatever I do to take care of the drainage channel will also be taking care of the parapet because I'm going to tie to it. So no, this is not a good design. They should have looked at, and following what you suggested, Steve, L sub A would end at my L sub C, which is, let's just call it 30 foot, call it 32 so we don't get in too bad a rut with 30 foot, okay? Would be end at 32. L sub A would equal 32. If I'm running my rail, I hopefully would flare it because I got some flat ground here till I get out to about here, okay, at an acceptable flare rate. And now you'd have to go to the formula from the roadside design guide, not the one in the standard, because it only addresses a parallel installation. But putting a parallel installation in here would not be a good design. You have available 10-to-1 grading to allow, and I'll tell you the number, if you put it in parallel, coming back here is going to be like 255 feet, okay? Where here we got, you know, maybe 80 feet total. So you're going to be way back up here. But if you flare it off, okay, you're going to be at a significantly less distance and still shield by the procedure the same amount of the hazard of the drainage, okay? So a very, very important place. Identify all of the warranting hazards. Now, going back to what I said, the quarry at 32 feet. I get to the 32 feet. If I go off at 35 feet and there's nothing to stop me from going 35 feet from this edge line, I'm in bad doo-doo. Well, TDOT, Ollie mentioned yesterday about you building dikes, and that allows you to come down here at a high speed and fly over it, Evel Knievel. Here, you got the guardrail, okay, working at 90 degrees, whether it will stop you. If this guy came down here, let's not use a truck, this guy came off here and headed to this at 60 miles an hour, I'm not sure this is going to stop him. And the dike is just going to put him up in the air probably. Okay, I just mentioned that Florida, when this is a traffic way underneath, Florida will use a concrete wall. It will stop you. Not very nicely if you're going any speed, but it will stop you. But anyway, if I put in my length of need, calculated length, I have theoretically, by the procedure, prevented me from ever getting in there. Well, that's the procedure. And maybe I even missed the end, and I can get here, out here at 35 feet, 40 feet, okay? And then I'm in the bad doo-doo. This is the endangered Tennessee crocodile habitat, okay? So what some states do, and what we have been advocating, is rather than limiting my L sub A to that 32-foot design clear zone, if this distance is less than some number, pick a practical limit, 70 feet or something, okay? I am going to design, use that procedure to design with LA equals 70 feet. Oh my gosh, you say that's going to double. I was using 32 for LA. Now I'm using 70 feet. My gosh, that's going to put in a medium barrier almost. No, go through the calculation and you'll find out it's maybe another 30 feet. That by the procedure now has shielded the whole opening here. Okay? This is the only place you're going to hear this. Okay? There's a couple other us that have been promoting it. And like I say, South Dakota has in their standards, if it's less than 80 foot, you will shield the whole opening. Okay? So whether I'm using 70 foot, if that's what the median is here, or whether I'm using 32, the designer here did not use either. Okay? Because even if we flared it, we probably need maybe 200 feet. And again, remember, the flare is at the maximum flare rate that is in the table on the type 12. And you use the formula that's in the roadside design guide that will include that flare rate. And you cannot flare it beyond where it is flat, including the earth pad. Okay? So this is a cry from me, Avita. Okay? So inadequate. See something else, it's still a freeway here, but this could be two-way, okay? Would I have adequate near side barrier? I have a transition, a guardrail to bridge rail connection, and I have right smack dab on top of that, my type 38, okay? Again, question is, what's my hazard? This does a fine job of shielding that concrete blunt end there. But what is this culvert or a bridge over? It's a drainage channel that doesn't look like one that you would say it's okay to go in. If you get into a drainage channel and that's no problem, you get your wheels wet or something, big deal. This would be all you would need. This looks a lot worse than this. So I should have been using, in this case, yes, my L sub A would be limited to my L sub C, because it makes no sense going more than that, okay? And the amount of barrier I would need, again, would be in the 250-foot range, okay? Now, if this were a two-lane roadway, for the LF, for somebody crossing this center line, okay, I'm going to use the exact same procedure, but now all my transverse measurements are going to be made from the center line, not from the white line. So remember I said I want to maximize my L2. I'm going to get an additional 12 feet or whatever your lane width is. That's going to significantly lessen how much barrier I need on the far side than what I need on the near side. But I apply the same procedure, just all measurements. My L sub A, which would equal the design clear zone, would be back here someplace, okay? Not to the same place it would be on the approach side, okay? So this, again, gets a F grade for adequacy. Try again. Still on the freeway. Why are we talking all these freeways? Because this is all the pictures I have, okay? So what do we have here? I think a pretty bad hazard. Where did it begin? I don't know. It looks like I have maybe it's a 12-foot shoulder, 10-foot shoulder, and then I've shoulder grading another maybe 8 feet, okay? 10 to 1, maybe it's not shoulder grading, but it's 10 to 1, and then I'm going down on 2 to 1. Well, that 2 to 1 is a hazard. Now, you may say, well, 2 to 1 only if it's more than 6 foot high. Well, when you're putting out barrier, here it certainly is more than 6 foot high. If you're putting out barrier for this, you may want to shield even through wherever the 2 to 1 is, okay? That's just whether I'll put barrier out there or not. I'm not going to shield something that I've made a determination that it is no worse than hitting barrier. But once I'm putting barrier out there because the depth of the fill gets deeper and deeper, I may want to redefine my beginning of point of need. That's just a judgment decision. Document what you do about it, okay? But anyway, this has about 0, if that, effective barrier, because the barrier is not effective to the third post here, okay, in advance of the hazard. Not only that, this is the non-energy type of terminal that if you hit this at any angle, it goes poof. If this were an energy absorbing, your current type 38, and you came down here and said, this is nice riding, and then you smack into it, you're going to be captured up here. Probably not go down there, okay? But with this type of terminal, it's doing nothing except shielding the end of the guardrail. So this never should have been put out here. Now, if we had gotten the full length of need that said if I bust through it or just miss it, then that's fine. And you'd rather hit this than hit your energy absorbing. But not in this case. You're in bad doo-doo. Okay? So we got another F. Geez, oh man, is anybody going to pass? Well, what do you think about this one? What's my hazard? Probably this. Probably not the 2 to 1 parallel slope. But if as I wrap my embankment here for the bridge around, if that transverse embankment, 2 to 1 slope typically, transverse looking right at me is within my design clear zone, then my design clear zone is going to be my back of hazard, okay? Because you don't want to hit at a high speed a 2 to 1 transverse slope. It ain't going to be nice. So this again is where you have to look, and this is very, very often missed on bridges, whether it's a bridge over like this or a bridge under. We see the immediate, either the bridge rail or the bridge pier, and don't look at the other hazards, okay? So this is terrible. We haven't even have enough length of need to shield this, because if you use the back of hazard being the back of the pier and came back the L sub R and did the calculation, you would still probably need 197.735 feet. Just did the calculation, okay? It's not enough. It's poor. Also remember, same as we talked about on the drainage under the bridge, make sure you've evaluated all hazards. I'm getting tired of seeing this. Oh my gosh, we saw this before. We talked about it. But we didn't go through quite as much as I'm going to go make you think right now. If I had a poll, I'd put it up, but I don't. How many people think, hopefully you all think this length of knee is inadequate. We already said that. But if I asked you, what is the value of the length of need? You should all answer me and say, mine is 12.5 feet, assuming that the delineator is right at the beginning of my hazard, the cut to fill transition. Remember, the first 12.5 feet of this type of terminal is not available. And notice this plastic delineator. This is on the traffic side, but probably no problem having something back here on the back side to keep those mowers from taking these out, Mark, for your question. Okay. So what the point is here, how much is being provided? A negative 12.5 feet, okay? So just terrible. They didn't even rate a not adequate. They rated a double F, okay? So how simple it is to do it right. You identify the hazard. You generally, not never, go more than, but you generally limit it to the clear zone. If it goes on forever, yes, you're going to limit it to the clear zone. But for the type of examples that I brought up, the quarry, the opening between the bridges, think a little outside the box, and it doesn't add that much, even though intuitively you would think it did. Go through the numbers, go through an example with LA equal 32, with LA equals 68, 66, okay? Assuming a 4-foot shoulder is the whole opening. Use the 360 L sub R for a high-speed, high-type road, and set your barrier L2 at, let's just say, 8 feet, and go through the calculations and see what the difference is. It's not going to be more than 35 feet, I'll bet you. Okay, so you identify LA. You identify where it begins, maybe simple, maybe a little more complicated. You go to the back of the hazard point, this is the procedure, okay, at the upstream end, and you snap a line from L sub R distance in advance to that point on the back of the hazard. That's the whole procedure. And then I'm going to put my barrier someplace between my edge line, hopefully not on my edge line, and the front of my hazard. Okay? The L sub R was just a lookup value. Here I'm going to determine my L2, how much I can move it off. I want to maximize it. Why? Because you see, it's going to extend from the beginning of my hazard to where it intersects this line. I call this line drawn from L sub R to the back of hazard my line of interception. Okay? This is where effective barrier begins on down here. You can see if I flared this, I would intersect it sooner. I need less barrier and it's farther away. This is what your formula calculates. The length of need, we're talking N right now for near side, of effective barrier, okay? Well, what about on the downstream side of a one-direction traffic? Remember I told you if it's coming the opposite direction as shown on the sketch, figure 8 or B, okay? You just go through the same procedure with all measurements made from the center line. But if everybody's going in one direction, then all I need to do is bring my barrier, the length of need plus the amount in front of the barrier, to where I no longer need effective barrier. Well, we typically use 25 degrees as the maximum angle of departure. So I could bring it down to where I intersected a 25-degree line coming back from the downstream point where I don't want to get. Well, that gets a little complicated in that. So we're just going to say use 90 degrees. It generally makes a difference of about 5 feet. okay? So we're going to bring our effective barrier to the end of the hazard. But in order to be effective barrier, remember I mentioned with the type 13, they have now found I do not have effective barrier at the beginning of the type 13. I got to come back 25 feet to that 7th post in order to have effective barrier. So the amount I'm going to have beyond the end of the barrier is going to be 25 foot of added rail and then my type 13. This is for one direction traffic. Locals probably don't have too many of these, but you could have a one direction roadway, a one-way roadway, okay? Not a divided roadway. And so this would still apply for a one-way roadway. Someplace where you're going to use a 13, which we said is only an anchor and cannot be hit by approaching vehicles. Okay, let's look at the combination alternatives here, okay? For on the downstream side of a hazard, depending whether it's one-way or two-way traffic, okay? So on the approach side, I'm just going to go through my length of knee procedure that's in the standard SP1, SPL1, okay? Calculate out that X value or LON. Realize that part of effective barrier is included in the terminal. Remember, if I have a terminal that's, let's go back to the old one, simpler to talk about, that was 50 foot long, and I had the BLON at the 3rd post, that said that 37 foot of that terminal was effective barrier. So I can include that in my value that I calculate out. I don't have to put out standard barrier for that. It's already effective barrier. So at some point on the terminal, I can include the part that's beyond the beginning of length of knee. Now, at the time you're doing this calculation, you don't know which terminal the contractor is going to pick. So I'm going to give you a nice number to use, but you use whatever you want. Just recognize that part of that type 38 or the type 21 is effective barrier. The part beyond the BLON, typically 12.5 feet to 16 feet. So on the advance, I know what I'm doing. I'm providing an earth pad for the terminal. I'm calculating out how much that is, and that's going to be, you know, just do it to the nearest foot. This is not that exact, but that's not the amount you're going to put in your bid. You're going to have barrier that may be going past the hazard. Again, that hazard may be 2 feet, it may be 200, it may be 2,000, it could be, no, it won't be 20,000, okay? So you're going to have that amount of barrier. Then you're going to look at the downstream for this traffic moving this way. What am I going to do? Case 1, one-way traffic, exactly what we just had on the last slide, a type 13 plus 25 linear foot of standard guardrail. Okay, for you guys mostly, two-way traffic. The hazard itself is inside the clear zone as measured from the center line to the back of the hazard. I'm just going to go through the same procedure that I did for the approach, okay? Two-way traffic, but the hazard itself is outside of the clear zone. The clear zone measured from the center line stops here. Okay, can you all see that? I'll show you how fancy I can do it. It stops right here, okay? Then you can end your barrier, effective barrier here, but it needs to be shielded because the barrier itself is inside the clear zone. So you just put a type 38 or type 21 on the downstream end. Case 3. Case 4, two-way traffic, but the barrier itself is beyond the clear zone. Now I'm going to go back to the clear zone is not a magic number. If the barrier itself was at 21 feet and your clear zone for this roadway was 20 feet, well, that says it's 1 foot outside. therefore it will never get hit. Wrong. I would still put a crash-worthy terminal. By definition, terminal is crash-worthy on the downstream end. It will develop the tension I need in the barrier, and it will make the end of that barrier safe, even relatively safe, even though it's outside the design clear zone. Is that a legal requirement? No. Is it a moral requirement? It certainly should be, and I'll give you an example of this coming up. Okay? So hopefully you understand these 4 different cases on what you do. One-way traffic would be where your whole road is one way and will never be used in a 2-way or traffic put on in reverse direction. Okay. After you've determined how much you need through and whether you need some beyond, and after you subtract off the part of the terminal you say effective, you'll take that length, divide it by 12.5 or 25, whichever you're typically using, to get the number of panels, because we're not going to put in a bid document, you need 192 linear foot of guardrail. It doesn't come that way. It comes in the 12.5 foot sections or the 25. So we want to put something in the bid document that's an even number of panels. Not even number, but is a full panels. Okay. So here's the example I was referring to, okay? So is this appropriate? Let's say this is a 2-lane roadway, and I went to my chart and my design clear zone was 20 feet. I had a 12-foot lane and I had a 10-foot shoulder, real nice road. So my available clear zone is 22 feet, okay? So this is 22 feet away from the center line, and my design clear zone was only 20. Okay, we're going to take a poll. Go to your reaction, and I want to know how many people are going to, this is on a resurfacing job, this is the criteria, okay, and this is what's out there. How many people are going to leave it as is? Say yes. How many people are going to say, oh my gosh, that's not very good. I am going to put a bridge rail, a guardrail to bridge rail transition and a terminal on the end of this. So yes, good as is. No, I need to shield, even though it's outside my design clear zone. L sub A is greater than L sub C. I am going to treat the end of this. So if you would, well, I like what I'm seeing so far. I went from 14 down to 13. Okay. Okay. Now give another 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, for those, remember, I can't see who you are, so you can say whatever you want. But I have a 23 to 3. You should be seeing that people are saying, no, I shouldn't do this. Again, legally, you should not lose in court from this. You are outside. But morally, 22 of you, did I lose somebody? 22 of you saying you would treat it. 3 of you saying you're going to leave it as it is. You don't have enough money to do it, okay? But if you have 12-foot lane and 10-foot shoulder, this is one of your higher type roads. And if you only had, 58 ET on this, you spend a lot of money on that road. I probably wouldn't do anything either, but I certainly would do something here if this is a 1,000, 2,000 ADT road and I had this situation, okay? So bottom line, what I use is my gauge, what I'm going to do. Can I go home and sleep well at night? Being a safety advocate, I may be a little more, but I'm also a cheap son of a gun. So I'm not going to spend a penny more than I need. If I don't think the risk is there, I'm not going to pay for it. But there's nothing magic about this 20 number I looked up, selected from the chart. Okay? Well, now it's your turn to work. Okay? And very simple problem. As you see here, I have a bridge over a deep river, and I have a fairly nice road with a decent amount of traffic, 1250 ADT. I got 12-foot lanes. I got an 8-foot paved shoulder, and I got a nice 6-to-1 foreslope. Okay? It's posted at 55. Okay, this is a new road, so I don't have it's going to be posted. I don't have an operating speed, so I'll use my design speed. Okay? So, what would you do for the northbound traffic? Okay? That is your charge. Are you going to leave it as is? Are you going to just build the bridge rail? I mean, it's not as is, you're building a bridge, and just build the bridge rails and say, that's good? Or are you going to do something? What all are you going to do? I want to know what's going to go in your bid document to treat this particular situation. And I will give you a half an hour plus 4 minutes. At 11 o'clock, we will come back and discuss what treatments we may or may not be applying here. Okay? Emma, I'm not sure I'm following your comment. Okay, hopefully you all had fun. Hopefully you were done after 5 minutes and were enjoying yourself even more fun. But I think this is not too uncommon a situation. Probably having available 6-to-1 front slope cleared for a clear zone width is maybe not normal. And so this is going to be one of those 75% times, or what would be normal would be one of the 75% times where you would not be able to get length of need, but the purpose of the workshop was to, if you could get length of need, one of the 25% times, how would you apply it? So we have the problem, bridge rail, and we know how to apply from the SPL1 with determining the appropriate parameters, how to apply it to come up with a LON N sub N, okay? And since we have 6-to-1 slopes on the side, we're not going to be flaring the standard runner rail. We will put in the earth pad and obtain our 1-foot offset for the first post of the terminal. So we will leave in our 0.75 to account for that offset on the terminal. Okay. So the first thing that we're going to do on a project is determine a clear zone value, which sets a general criteria that if we have something less than the desired design clear zone value that we don't like, we are going to evaluate it, first of all, with the first 4 priorities of moving it farther away, using something breakaway, etc. And once we determine we are going to be putting in, or let me also say, even if something were right outside the clear zone, you may, if there's a high risk, still want to shield that. But that's what we're looking for this clear zone value for, which is simply just a lookup value from the SCZ1. I say simply, but that dang Alley, he made it complicated. He doesn't give us one number. He is going to give us a range. So we look at the table and we have a range, okay? So now we're going to have to think a little more. We have the ADT that was given and the speed that was given as 60 miles an hour. We have what the cross section looks like. We had 6-to-1 slopes. And so we have the range of 20 to 24 feet. And now I have to say, well, what am I going to do? Well, 1250 is a little closer to 1500. So maybe I want to be a little more generous. 6-to-1 is steeper than a 10-to-1. So maybe I want to be a little more generous, but I'm not real generous. So I'm going to pick 23 feet. You may have picked 24. You may have picked 20. Okay. Your decision. That's what the range is for. Then within that design clear zone, and again, not using tunnel vision only for whatever number I pick, but looking at the whole situation, I need to identify the hazards and whether I can meet any of the 4 priority approaches of removing, et cetera, or whether I'm going to have to shield. And in this case, it's pretty obvious. I'm going to have to shield. I can't make a bridge rail breakaway. That wouldn't work, okay? And so the bridge rail is going to be obvious, very close. And then the river, which goes forever. And so I'm going to limit it to my design clear zone, the part of the river within my design clear zone, okay? So I've now identified my hazards. Now I just simply use the formula from the SPL1, okay? I have my design speed was 60, okay? And I have the traffic volume of the 1250. And so I have a very precise number given from the table. 210 is my L sub R, okay? Fixed, no argument. What if I had a design speed for some reason of 55? Well, your choice. You could use 210 or you could interpolate between 160 and 210 and get 185. Doesn't matter. It's just a procedure. You use it as you think appropriate. So now I've identified my hazards. Now I have to identify the physical extent of my hazard. I know where the back of the bridge rail is, but that's going to be covered by the back of how much I'm covering of the river. Okay, so I am going to limit my back of hazard on the river to my design clear zone. I can't pick another number that's more reasonable like I did in the median opening, the dual bridges, okay? So whatever I do to shield the river, I will be taking care of the bridge, except I will have to have a special attachment to the bridge called my guardrail to bridge rail attachment. Where am I going to place my rail? Well, I have to follow my 5 principles. I would love to flare, but I can't because I'm not going to do all the grading to put in a 10-to-1 slope for some distance coming out. Some places will do that for a short distance. Okay, there's the advantages we talked about, but typically I'm not going to do it. I don't have curb I don't have to worry about. I have a 6-to-1, which only gives me the allowance to place a 6-foot long post with the face of rail at the slope break point on my 6-to-1 slope. Not the general guidance, just thank Ollie for giving you that, doing a reasonable practical approach, okay? So the L2 will be putting the face of rail at the slope break point at the edge of the shoulder. That's as big far as I can get it. I cannot move that face of rail down the 6-to-1 slope. That is not allowed, okay? So my L2 is set by the slope in front criteria and the soil support criteria of the 5 principles. Since I don't have curb, I don't have to worry about that. And I've taken care of my 5 principles. So now I'm just going to put this configuration into my formula, whether we'll first go in for the near side, okay? Like I say, we can take advantage because with a 6-to-1, I can build the earth pad at not too much trouble and not have what Dick Albin was mentioning yesterday. We see earth pads around the country, and then there's a 2-to-1 slope going off of it. That's not what we want. The earth pad should have that nice 4-to-1 slope beyond the flat platform. We can build it. We can get our 1-foot offset, so we can include that in the formula. And we go through, plug in the values, and we come up with 130 feet. What is 130 feet? That length of need is from the beginning of the hazard. What's the beginning of the hazard? The bank of the river to the BLON place on my terminal. So how am I going to make 130 foot of effective barrier in advance of my beginning of hazard, the bank of the river? Okay, well, I got the bridge rail up here, which I said is 24 feet from the bank back to the end of the bridge rail. Bridge rail is effective barrier. It passes all the tests. So 24 foot of this is contributing towards my 130. Okay, I am going to have that bridge rail transition, guardrail to bridge rail transition, in order to tie guardrail to that rigid bridge rail. And your standard, the SGRC4, the thrive beam with the asymmetrical element, is 18 3/4 feet. That's not the pay item. That's the length of the effective barrier, because it's part of your pay item, which is 20 feet or something like that, is part of the end shoe, which is a part of this 24 feet. So using the 18.7.8, okay, I just used the exact number there, is good. Now I need a type 38 since this is 60 miles an hour, okay? And I said that part of the type 38 is effective barrier. Since it's a variable depending on which element or which product the contractor chooses, their choice, okay, I'm going to pick a number that's pretty representative of what's out there, okay? It may be a little less, but close enough for government work. I'm going to use 35 feet of my terminal as effective barrier. So I'm going to take my 130 and subtract off these three contributors, okay? So I take off the bridge rail portion, take off the transition, and take off the portion of the terminal that's effective, and I end up with 52.2.3 feet, okay? Since I don't have to worry about, I'm going to have a set number of panels between the end of the transition and the end of the terminal. I can go through and round this to a even panels, okay, which means it's a factor of 12. So I'm going to have 5 panels at 12.5, which is 62.5 feet. I am going to have a pay item of 62.5 feet. Remember, I will also have the earth pad. And if this is a project that doesn't have any other earth embankment on it, you need to have a separate bid item. Earthwork, earth pad, by cubic yard, by truck measurement. Okay, we're not going to go out and take sections. We're just going to do the easiest thing to determine close how much dirt the contractor puts out there, and you'll need to have a spec on what the density will be. Okay, pretty easy. That took all of 12 minutes. Hope you all did that. But that's only half. I said northbound traffic, and somebody can go northbound and cross the center line because that's not a median barrier. It's just a yellow line on the road, and they could go across and either hit the end of the parapet on the far side, okay, or miss that and go into the river, okay? So the difference here is that all measurements are now made from the center line, okay? So I have a 12-foot lane for the southbound lane, and my 8-foot shoulder, I got 20 foot to the face of my parapet. That parapet, no question asked, is inside my design clear zone. But my design clear zone is 23, continues forever, so I'm going to stop my LA at the LC equal 23 feet, okay? So I don't have to worry about shielding the end. Whatever I do for the extra 3 feet or 2 feet, whatever it is, of hazard, will be taking care of the bridge rail. So again, recognizing that these measurements, the values stay the same, but the point of measurement is going to change. So my LA is the 23 feet. My LR stays the same, no difference for that. The distance from the beginning of the hazard, the bank here, up, which we picked off as 210, okay? And my L2 is going to change. It's the distance from my center line to the face of my barrier, okay? So its value is going to change to be exactly what I said before, the 12 plus 8, or 20 feet, okay? So I just plug these values in. Again, since I have the 6-to-1 slope, I can put the earth pad in, get my 1 foot offset. So I just grind out the numbers there for my LON sub F, okay? And the value that comes out is 66 feet. 66 feet of effective barrier from the bank of the river to the BLON of my terminal. So the same thing, I got 24 feet here of effective bridge rail. That contributes to the 66. I have my transition, again, 18.8 feet. And I have that same portion of the TL, the type 38, that contributes, I'll use the same 35 feet. I am going to subtract these values from 66. Well, I think you can look at it and pretty quickly tell that's going to give me a negative. I need each one of them. I need the bridge rail. I need the transition. So I have satisfied my length of need. But remember, I told you, there's a possibility on a type 38 that you can push that head more than the length of the terminal, so that we want to have one additional panel. So you will have the bid item of the bridge rail as part of the bridge, the bid item of the transition, the bid item of the terminal, and you will have 12.5 feet of guardrail for this location, okay? So, pretty simple, right? My question then, if you answered yes, how many times do people mess it up when they can't get it? Most of the time, you're going to have a slope off of this on your local roads going down at 2 to 1. You will, if you do have a bridge this wide, it will taper back in to have maybe a 2-foot shoulder. If you're lucky, you got the 8-foot shoulder. So you got a 2-foot shoulder and then a 2 to 1, okay? In that case, you're going to have a transition. You will taper the rail back, use your 8-foot long post with the face of the rail at the face of the shoulder break point. And how far will you bring it back? Whatever you like, okay? Because it's no ability to calculate out the length of need. I wouldn't know what to tell you to use as an L sub A. So I can't use the formula. And you certainly are not going to be adding in the 3/4 foot, because with the 2 to 1, you're not going to get the earth pad. What you are going to make sure you get is you have a bid item for getting some grading there, and you will document the grading won't satisfy the full earth pad, but you will satisfy the stub height criteria. Okay. Stacey, are you saying I can't do math? It may be, whatever it comes out. And Joe, thanks for doing it. If that's what you used and that's what you came out with something else, that's fine. Oh, you're checking my math. Calculate, wait a minute. Let's go back to Matt's. Received this from Bruce. The math is wrong on the far side, okay, for the northbound. 20.5 feet, maybe I didn't change, I'm not sure what, but it's going to be less than the length that I get from the 24 feet and the transition and the portion of the terminal. That's what I was trying to demonstrate, that this is fairly common occurrence for that left side, the far side of the approach traffic to a bridge, okay? So whatever the math is, I'm sorry, I can't do math. And the question from Emma, if the parapet wall itself is a hazard, okay, great question. How can we count it in less than need? The parapet wall is not the hazard, and I use that terminology, and I did it incorrectly. It's the blunt end of the parapet wall. Once I turn the corner, I'm hitting on the side of the parapet wall. That is standard barrier, so that can be used, okay? The hazard is the blunt end of it, just like the blunt end of a W-beam is the hazard, and that's why we put a terminal on it. The side of the terminal is not a hazard. It's our redirecting barrier. So great question. Thanks for getting me straight on that. Okay. So besides me not being able to do math, does anybody have any questions on this? Okay, I think this is the dream world where we can do the full length of need. I lowballed it when I said 75%. I think most of your jobs, you're going to be 90% not able to do this, okay? And you're going to have to make a decision how far back you would bring it. If that 2 to 1 slope with trees on it or trees at the bottom went on back 5 miles, you're not going to carry 5 miles of guardrail, okay? But you should put at least the full transition and the full terminal and How much more you add, that's up to you. Make sure you can sleep at night with what you do, okay? But don't go leaving it exposed. Don't go attaching directly with a terminal. That is not acceptable, okay? So Jonathan's asking why the one panel of standard guardrail. Okay, remember how these terminals, the Type 38s, worked. You hit on the end. If you're hitting at a shallow angle, you're going to push that extruder head, whether it's an MSKT head, an SGET head, or the soft stop head. Excuse me. Great question. I want you all to understand. It's going to move down the rail, work on the rail. For the MSKT, it kinked it, remember? For the SGET, it flattened it. And I didn't tell you this, but for the soft stop, it pancakes it. It crushes it down to make a pancake out of it, okay? But that work on the rail, and for the soft stop, also the friction of pushing that extruder head down the rail, they combine to accept all the energy under the test condition of a 62 mile an hour impact, 0 degrees by a 5,000 pound pickup. How far did those heads go? Well, for the MSKT, I can tell you the bumper of the vehicle went 51 feet, okay? That means the extruder head, which is another 5 foot long or so, went another 5 foot, went 56 feet. Your pay item for it is either going to be 53 or 47, okay, whichever you're getting. Either one, the head went beyond the end of the pay item. That's why we put the extra rail in there, because if you hit it at 90 feet and you didn't have the asymmetrical element at the end, you may push that head, I don't know, 75 feet down and bring the vehicle to a safe stop. There's a lot of excess capacity in these systems, which is great. Let's not ruin it, okay? So, like I said, most of the time you're going to be calculating out like you did on the right side, and you're going to have barrier some length of need in there, okay? But for the situation where when you calculate out your length of need, there is no length of need of standard barrier, but you have this asymmetrical element that will not allow the head to go through it. That's why we put the one panel in. Boy, was that a long explanation, but hopefully that did explain it, okay? Any other questions? Well, you have to see my beautiful drawing, okay? Again, don't forget about grading and having a spec for the density on that and paying for that grading as a separate item, measurable item, truck measurement, truck weight, whatever, but not as a calculated out value, volume, or a surveyed value. How do you like that, beautiful? And since you all told me I can't do math, excuse me, that number would be wrong, but the drawing would be right. I have here the transition and here the terminal. Okay, so beautiful. Thank you. So we already went through how this would be the one panel that would be in your bid item for that side, that station left versus station right. Okay, Joel asked, would the clear zone for the far side need to include the additional 12-foot lane since it is being measured from the clear zone? Yes, the back of the clear zone, back here for the northbound traffic on the left side is 23 feet measured from the center line. So it's only that 2 feet or so behind the bridge rail, okay? All measurements, whether it's back a hazard, clear zone, L2 to the face, the offset of the barrier for the opposite direction are measured from the center line, okay? If I have 4 lanes over the bridge, 2 lanes in each way, then I'm going to have, if they're 12-foot lanes, 24 feet, okay, plus my shoulder. Let's say that comes out to 32 feet. If you still only had a 23-foot clear zone, remember there's a slide that says excessively beyond your design clear zone. I would maybe leave the end of that blunt end of that parapet unprotected, but I doubt that would ever happen with me, okay? I'm probably going to have the exact same treatment here, okay? Good question, Stacy. Would that extra length be accounted for in minimum installation? SPL3, you're going to make me go and pull up SPL3. Okay, great question. I do remember that these are in here. I'm going to say probably not. Ollie and I have had these discussions, and so this is probably not yet included in SPL3. Thank you very much for bringing that up. So if we just have a transition and then a terminal, it would not be included in this. The way I'm looking at it without, well, I'll blow it up for you. Let's look at the type 38. Okay. We have the 20 feet, which is the 1875, okay? And then we have the type 38 attached on. So the answer to that question is no, okay?
Bill, we are revising the standard. Yeah, we are revising the standard to add a variable length at an increments of 12.5 to meet length of need. So this is under revision, addressing that issue.
Okay, and I would add in with a minimum of one panel.
Correct, correct.
Yeah, yeah. Great question, Joel. Thanks, and thank you, Ollie, for advising on that. I should have shut up in the first place. But I can't shut up, except now I'm going to shut up because I'm going back to the PowerPoint, and what it's going to tell me is we are done. Okay? We went through, and hopefully you have a good feeling that when you can apply, you understand what length of need is, and you will apply it. You saw those horrible examples. Okay, you're all saying he doesn't even know how to make a presentation mode. Okay, and then you worked. Okay, so hopefully this will help you. Remember who you're doing this for, the traveling public, AKA you, AKA me when I come to visit Ollie, okay? Make it safe for me, please, as much as we can. Okay, that's it. Done at 11:30, half an hour out to get extra for your lunch. Again, if anybody's planning on coming back this afternoon, I just got a terrible look. I know what she's going to say. You have a survey monkey to fill out, okay? Please do that in that 30 minutes extra we gave you. You'll only take 2 minutes of it, but please fill out the survey monkey, which Karen is putting where? Matt's putting it up for you. There it is. Say something, and whether it's Matt or Karen, presto, it's done. Okay, please do that. Anybody who is planning on going through the installation part, the first part of Module 2B is going to be the same as what we did this morning without talking about installation on a curve, because that's part of that second session in that module. And since it took this morning about 45 minutes, excluding the extra stuff I threw in, I would come back about 1:45 to see the second one. If you want to sit through the first one again, session 5, great. If it's helpful, that's what we want. We don't want to waste people's time. But please do the Survey Monkey, and hopefully it was time that you have spent so far, if that's the total, been beneficial for you. and we'll allow you to raise the bar in your jurisdiction. So any questions? We're here. We got an hour and a half before we start. At any time, if you stay on, you can send up a question or whatever. And thank you, Emma. Thanks for the good questions. So, and for all you who want to point your finger at me that I can't do math, screw you. No, I didn't say that. I will go back and I will check my math and see what happens.
Yeah.
Okay, go ahead.
Hey, Bill, this is Matt. I was just going to say, for those of you who can't get to the SurveyMonkey link there in the chat box, or maybe you're not on the best computer to do that, we'll send that out by email probably tomorrow.
Okay, great. Anything else, Matt?
I think that's it for me. We'll probably close the session down and come back at 12:30 or so, open it back up again.
Oh, okay.
For the afternoon.
1 minute since Ali sat through this whole thing again. He's getting tired of hearing me.
Sure.
Ali, have anything to add?
Yes, I do. Actually, the length of need calculation spreadsheet is provided by Federal Highway Administration. So the calculations, the hand calculations are very simplified under Excel file. You will find a link in our website. So.
Okay, recognize on the federal highway, and several states have it. It does not include, I don't believe, your 0.75 credit that you're taking for the offset of your type 38 terminal. It can be worked in there. If it's not in there, I'm not sure it is or not, but yeah, this is so easy. Don't go to some, I mean, it's like, Ali's absolutely right. It's available to you. It's in the link, but this you can do in your head almost, except for me, since I can't do the math. Okay, so take advantage of the tools that you have, but recognize that it could be a little difference on that. I'm sorry, anything else, Ali?
No, that will be all. Thank you so much for your time.
Okay, well, and thank you for your time, and you people out there, Ali is a great, great resource. And under that are the mentors. The mentors are not under Ali, they're under maintenance, asset management, but they are also there to be a help to you. So nobody can do this all themselves. More than one head's better than just the one, but let's just work on doing the best we can. So thank you all. Appreciate your attention.